In section 1.5, we're going to be looking at relationships between angles. So two angles are called adjacent angles if they share a common side and a common vertex, but have no interior points in common. So in this diagram, angle PQS and angle SQR are adjacent angles. Ray, QS, is the shared side and Q is the shared vertex. Vertical angles are two non-adjacent angles, and if they are formed by two intersecting lines. So this is like we saw in our geometer sketchpad activity. So in this case, angles 3 and 6 are vertical angles, and angles 4 and 5 are vertical angles. And as we learned in our activity, vertical angles have equal measure. A linear pair is formed by two adjacent angles as long as their non-common sides form opposite rays. So what that means is if I have a single line and I have a ray coming off of it, then as long as there are only two angles, then those are a linear pair. So because they form a straight angle between the two of them added together, the measure of angle 1 and the measure of angle 2 equals 180 degrees. We're going to use this fact to solve a problem. So if the measure of one angle is 3 times the measure of the other, then I know that the total must equal 180 degrees. So 4x equals 180 and x equals 45 degrees. So one of my angles equals 45 degrees. And the other one is 3 times that, so it is 135 degrees. We can use the relationships between vertical angles and linear pairs to solve some semi-complicated problems. So in this example, we're going to use the diagram, and we're going to first find the value of x. So how we're going to do that is we're going to look at our two angles that have x, and they form a linear pair. So I know that 3x plus 5 and then added to x plus 15 must add up to 180 degrees. So when I combine these, I get 4x plus 20 equals 180, 4x equals 160, so x equals 40. But I'm not done. I also need to solve for y. So we'll do that second. Again, our two angles that have y form a linear pair. So y plus 20 plus 4y minus 15, all of that adds up to 180. So I have 5y, and then 20 minus 15 is still a positive 5, equals 180. So 5y equals 175, or y equals 35. So I found the values of x and y, but what I still have to do is find each angle measure. So I'm going to do these one at a time. The measure of angle AED is 3x plus 5, and now I'm just going to substitute. So 3 and then x is 40 plus 5 is 125 degrees. The measure of angle DEB is x plus 15, which is 40 plus 15, or 55 degrees. Now, I could just use my vertical angles and figure out what my other two are, but let's actually plug these in and make sure that it works. So the measure of angle AEC equals y plus 20. In this case, y is 35 plus 20 is 55 degrees, which does line up. And then the measure of angle CEB is 4y minus 15. So that is 4 times 35 minus 15, which gives us 140 minus 15, or 125 degrees. And so those are our answers. Our next two vocabulary words are complementary and supplementary angles. So two angles are complementary if the sum of their angle measures is 90 degrees. They can be adjacent or they can be non-adjacent. So I can write this as an equation, and there's two examples shown here. And if I have one angle and another angle is complementary to it, then the other angle is called the complement of the first angle. Supplementary angles add up to be 180 degrees. And so I can write this in an equation like this, and then each of these angles is the supplement, that would be the noun, of the other angle. So we're going to use these relationships to solve some problems. So if I have angle 1 and it is a complement of angle 2, so I know before I do anything else that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And I remember this because C comes before S in the dictionary and 90 is less than 180. So once I have this equation, now I can plug in my given value, M1 equals 68. So the measure of angle 2 is my unknown, and that equals 90. So when I subtract 68 from each side, I get that the measure of angle 2 equals 22 degrees. In our next example, we're going to have the angle 2 be a supplement of angle 3. So I know that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And now my given is that in this case, the measure of angle 2 is 68 degrees. So I'm going to solve for the measure of angle 3. So 180 minus 68 is 112 degrees, and that is my answer. We can also use our complementary and supplementary angle relationships to solve more complicated problems. So here I have angle DEF, which is 7x minus 3, and I have angle GEF, which is 12x minus 7. And because these form a straight line, they are supplementary, and so they add up to be 180 degrees. So now I'm going to solve for x first before I find the measures of my two angles. So 7 plus 12 is 19x, negative 3 minus 7 is negative 10, so that's 180 degrees. So 19x equals 190, or x equals 10. Now that I have x, I can find the measure of angle DEG equals 7x minus 3, which is 7 times 10 minus 3, otherwise known as 67 degrees, and the measure of angle GEF equals 12x minus 7, which is 12 times 10 minus 7, or 120 minus 7, which is 113 degrees. In our next example, we have two complementary angles, so they add up to be 90 degrees. Again, we have to solve for x first. So I know that 6x plus 4x equals 90. And so I have 10x is 90, or x equals 9. And from there, I'm going to solve for the measure of angle DEG, because that is 6x, or 6 times 9, which equals 54 degrees. And then the measure of angle GEF equals 4 times 9, or 36 degrees.